Welcome to Spring LIB.
So the first compound here we have is LiClO4, and since it is an ionic compound which completely dissociates into its ion in an aqueous solution, that means it's a strong electrolyte, as strong electrolytes are completely ionized in an aqueous solution. Then we have HClO, which is so hypochlorous acid is a weak acid, and that's why it will be slightly ionized in aqueous solution, and that's why it is a weak electrolyte. And then we have the propanol, which is CH3, CH2, CH2OH. And propanol, since it's an alcohol and it is not ionized at all in its aqueous solution, it just dissolves at a neutral molecule in the water. That means it's a non-electrolyte. Then we have the HClO3, which is a strong acid. That means it will be completely dissociated into its ions as H plus and ClO3 minus, and that's why it is a strong electrolyte. Then we have copper sulfate, which is an ionic compound, and it will be also completely dissociated into its ions. That's why it is also a strong electrolyte. And finally, we have sucrose, which is C12H22O11. And it being an organic compound, it will not be ionized in its aqueous solution, and it will not produce any ion, and that's why it is a non-electrolyte. So the bottom line of the discussion here is strong electrolytes are basically strong acids, and then strong bases or ionic compounds which completely ionizes or completely dissociates into their ions in an aqueous solution are strong electrolytes, and those who slightly dissociate in its aqueous solution to its ions are weak electrolytes, and those they which remain as a neutral molecule in its in the aqueous solution are called non-electrolyte.